Ever heard of the Fermi Paradox? The answer to why we haven't found extraterrestrial life yet. But what if we told you we were lied to? Let's break it down. The Fermi Paradox is a contradiction, a puzzle that has been boggling the minds of scientists for years. It's named after physicist Enrico Fermi, who during a casual lunchtime chat famously asked, "Where is everybody?" He was referring to extraterrestrial life, of course. According to the laws of probability and the vastness of the universe, we should have bumped into ET by now, right? But here's the thing. We haven't. Not a single piece of evidence. No intergalactic phone calls, no alien postcards, nothing. And this, ladies and gentlemen, is the Fermi Paradox. It's the cosmic equivalent of throwing a party and nobody showing up. To explain this paradox, scientists came up with the Drake equation. Named after astronomer Frank Drake, this equation is a way to estimate the number of civilizations in our galaxy, the Milky Way. It factors in variables like the rate of star formation, the fraction of those stars with planetary systems, and the number of planets that could potentially support life. And here's the kicker. According to the Drake equation, there should be about 10,000 civilizations in our galaxy alone. 10,000. That's a lot of potential cosmic neighbors. But here's where the plot thickens. We've sent out radio signals, we've listened with our giant radio telescopes, and we've even sent a golden record into space, hoping for a response. But so far, it's been eerily quiet. So, we return to Fermi's question, where is everybody? Could it be that we are alone in the universe? Or is there something we're not seeing, something we're not understanding about this cosmic conundrum? But hold on, what if the numbers we've been given are wrong? Let's delve into the Drake equation, where the deception lies. A cornerstone of the search for extraterrestrial intelligence, the Drake equation estimates the number of civilizations in our galaxy with which we could potentially communicate. But it's here that the potential for deception takes root. At the heart of the equation are three key variables that significantly influence the outcome. The rate of star formation, denoted as R*, the fraction of those stars with planetary systems, represented as Fp, and the number of planets that could potentially support life, or N. To put it into perspective, let's start with R*. This is the average rate at which stars form in our galaxy. Scientists estimate that it's around 7 per year, but this number is subject to change as we gather more data and refine our understanding of the cosmos. If the actual rate is higher, the number of potential civilizations skyrockets. If it's lower, the number plummets. Now let's consider Fp, the fraction of stars that host a planetary system. Current estimates suggest that almost all stars have planets, but again, the actual fraction could be significantly different. And as this variable shifts, so does the estimated number of civilizations. Lastly, we have N, the average number of planets that could potentially support life per star that has planets. This is perhaps the most contentious variable of all, as it hinges on our understanding of what conditions are required for life as we know it. If we discover that life can thrive in conditions vastly different from Earth's, the potential number of life-supporting planets could be far greater than we currently imagine. However, the broad range of estimates for these variables exposes the potential for deception. With such wide-ranging estimates, we're left with a Drake equation that can spit out wildly different numbers of civilizations depending on which estimates we plug in. What happens when we tweak these variables? The number of civilizations drastically change, hinting at the possibility of a cosmic cover-up. Ready for the scary truth? Let's delve into the Great Filter Theory, an explanation that haunts the minds of physicists and astrophysicists alike. This theory suggests that the reason we haven't detected other civilizations is because they've all self-destructed before reaching a point where they could communicate with us. Consider our own civilization. We've come dangerously close to self-destruction several times. Think about the Cuban Missile Crisis in the early 60s, where we teetered on the edge of nuclear war. Or remember the Chernobyl and Fukushima nuclear disasters, which showed us our vulnerability to our own technological advances. Our environmental destruction is another chilling example. The World Wildlife Fund warns us that in the last 50 years, we've seen a 68% decrease in wildlife populations. United Nations reports suggest we're on track to increase global temperatures by more than 2.5 degrees Celsius by the end of the century, which would result in catastrophic climate change. These aren't just isolated incidents. They're part of a pattern that we see across our civilization, and they're not confined to Earth. Any civilization advanced enough to reach out into the cosmos could potentially fall into the same traps. Let's crunch the numbers. If we assume that 1 in every 100 stars has a planet capable of supporting life, and 1 in 100 of those develops a civilization, that's still 100 million civilizations in our galaxy alone. But if 99% of those civilizations destroy themselves before they can communicate with us, that leaves just 1 million. And if those civilizations only last a few thousand years before meeting their end, the chances of us overlapping with them are infinitesimally small. The numbers show a sobering truth. The silence in the universe might be the norm, not the exception. Each civilization might be like a solitary ship passing in the night, alone in the vast ocean of the cosmos, never encountering another. Could we be alone in the universe after all? So, how were we lied to? An intriguing question, isn't it? It takes us back to the Drake equation, a formula that has been used as a beacon of hope for those searching for extraterrestrial life. But what if I told you that the optimism that surrounds this equation was more of a marketing strategy than grounded science? Let's dissect the Drake equation. It's a mathematical formula used to estimate the number of active, communicative extraterrestrial civilizations in the Milky Way galaxy. It's filled with variables, each more uncertain than the last. The equation was designed to stimulate scientific dialogue at the first scientific meeting on the search for extraterrestrial intelligence, or SETI. But here's the catch. The numbers in the equation, the ones that have had us looking to the stars with hope in our eyes, were inflated. They were optimistic to the point of being unrealistic. Why? To foster interest in SETI, to keep the search alive. The promise of a universe teeming with life was too enticing to resist. So, we were seduced by the numbers, and in the process, our perception of the Fermi Paradox became skewed. Remember, the Fermi Paradox is the contradiction between the high estimates of potential extraterrestrial civilizations and the lack of evidence or contact with such civilizations. But if the estimates were inflated, then maybe the paradox isn't as paradoxical as we thought. What does this mean for the future of our search for extraterrestrial life? One word: astrobiology. This interdisciplinary field is paving the way for more targeted searches, focusing on biosignatures or signs of life. Scientists are honing their abilities to detect these subtle clues in the vast expanse of the cosmos. And here's a truly thrilling prospect: the upcoming launch of the James Webb Space Telescope. This marvel of modern science promises to revolutionize our understanding of the universe. It's not just a telescope, it's a time machine, capable of looking back over 13 billion years to see the first galaxies being born. The data from these ventures might help us refine the Drake equation, offering a clearer picture of the Fermi Paradox. Is the universe teeming with life, or are we just shouting into an empty void? While the truth might be scary, it only makes the search more exciting.